So in this last little vignette for Chapter 1, we're going to use our dimensional analysis skills to solve problems that are multi-step, meaning they require more than one conversion factor to solve. And so this is actually a screenshot from your online book on MindTap, showing how to kind of do a roadmap and how to solve dimensional analysis problems that have more than one step. And I kind of like how they lay out the roadmap, and I think that that's useful, particularly when you're starting out or refreshing your skills, so you can see clearly what unit needs to be converted when. As you get more skilled, more adept at doing unit analysis problems, you probably will not need to do a roadmap, this little column here, but I really like the way that they set up, or the way they show how the problem is solved, because they clearly write down the number and unit for not only for each part of the conversion factor answer and the given, and it shows how the unit, shows the units canceling properly to give you the unit that is desired. So I would encourage, or I definitely recommend, and in class I will use this solve method to set up dimensional analysis problems. If you're getting, for a refresh, if you need to do this little roadmap factors to the side to kind of map out what conversion factors you need to use when, that's great as well. But I really like the way that they show how to solve unit analysis problems in this way, because it will serve you well as we continue in chemistry and when we continue doing calculations regarding balanced chemical equations. But let's go ahead and use that skill in 3 separate problems. And yes, you do need to remember significant figures for the final answer. So let's go ahead and do this first one. It says convert the speed of light to mph. So a few things to unpack here. Now, as of always, I tell you to write down number and unit of the given. And in this case, the given is 3.00 times 10 to the 10 centimeters per second. And the way that it's written here in this first typeset, the slash is to the side just for ease purposes, but I really recommend when you write down your givens and your conversion factors, make sure you clearly show that you have a numerator and a denominator. So I have rewritten my given to clearly show you that the second, specifically the 1 second, is in the denominator. And then the 3.00 times 10 to the 10 centimeters is in the numerator. And then to mph, that is basically short for miles per hour, I've clearly written that so I can see that the miles is in the numerator and the hours is in the denominator. So that's the first point I wanted to make about this problem. Make sure that when you are given a unit that has, or a measurement that has a numerator and denominator, make sure you clearly write that down so you can see what unit is where in the numerator or the denominator. Okay, so now with this problem, we sort of have double trouble because we have 2 things we need to do. We need to convert our centimeter unit to miles, and we also need to convert our second unit to hours. So the way that I really recommend students doing these problems that have a unit in the numerator and in the denominator is to set up the problem all in one long strand. Once you're finished, or once you have an answer with the units that you desire, in this case miles per hour, that's when you put it in your calculator. So it doesn't really matter, since you're going to do it all in one long calculation, it doesn't matter if you start with centimeters, if you go from centimeters to miles first, or seconds to hours first, because both of them need to get done. I went ahead and I decided to do centimeters. I went ahead and decided to do centimeters to miles. There's no direct conversion factor to go from centimeters to miles, but I do know that I can go from centimeters to inches. This is a conversion factor that you need to memorize. And I've written it so my centimeter units cancel. And hey, I can convert that inches to feet My inch units cancel. And that's helpful because if I'm in feet, I remember that in 1 mile, there's 5,280 feet. And again, I've written that, so my feet unit cancels and I'm left with miles in the numerator. And so now the problem is half done. I've got miles in the numerator, and that's the unit I want in the denominator. All that's left is we need to convert my denominator, because if I was to just put this in my calculator now and write down the answer, that would be in miles per second, and I need miles per hour. So I need to convert the seconds first to minutes by saying 60 seconds in a minute, and I've written the seconds in the numerator, so this seconds unit right here cancels all the way with this second unit down here. And then finally, I need to go from minutes to hours, 60 minutes in an hour. And now I am left with the units that I am interested in. I've got miles in the numerator, and I've got hours in the denominator. So now I am set up to put this in my calculator. And as I said in the previous video, all new numbers that are in the numerator get multiplied. Numbers that are in the denominator get divided. So 3.00 times 10 to the 10, divide by 2.54, divide by 12, divide by 5,280, multiply by 60, multiply by 60. And what comes out of your calculator, and our answer is going to be to 3 sig figs, because we have 3 sig figs in up with our given. And remember our conversion factors, those all have infinite number of sig figs. So to 3 sig figs, the answer that you should get is 6.71 times 10 to the 8th. So that's a good representative problem, I think, for doing a dimensional analysis, not only with more than one conversion factor, because we needed several here, but also dealing with a conversion or dealing with a measurement that had a unit in the numerator and a unit in the denominator, both of which needed to be dealt with. Let's do a second one. So we have here a block that occupies an area. Ooh, I know it's an area because I see that cubed. Remember, an area or a volume. We know volume is cubed. It was in the previous video. So I have a block with a particular volume, 0.2587 foot cubed. So there's my given. Oh, and I just saw, sorry guys, I'm doing it too quickly. 2587. I'm doing this video too quickly, I guess. And I want to know what is the volume in millimeters cubed. And I do give you a hint. I do say that 1 meter is that many feet. So the thing that you've probably noticed about this problem that's different, aside from my typo here, is that we have units that we need to convert that are in cubed. But all of the conversion factors that I've given you so far, aside from the fact that 1 milliliter is equal to 1 centimeter cubed, all of the conversion factors I've given you so far are just, regular, aren't cubed or aren't squared. They're just regular conversion factors. There's no cube. So how are we going to deal with the cubed portion of this problem? Well, it turns out to be fairly easy. If you remember your algebra rules, if you remember in algebra, if you manipulate one side of an equation, if you do one algebraic operation to one side of an equation, you can do the same thing to the other side. You need to do the same thing to the other side. It's the same thing with conversion factors. So I know, if I can write it here, I know, because I gave it to you up here, that in 1 meter, I have 3.281 feet. So I've written that. So my feet units cancel, but I need that to be cubed. So I'm going to cube both my numerator and denominator of that conversion factor by putting a little cubed out there. So just as 1 meter is equal to 3.281 foot, I can say that 1 meter cubed is equal to 3.281 foot cubed. And that's great. That's helpful because now, hey, my foot cubed units can cancel. and I'm left with meter cubed. And hey, if I've got meter cubed, I can go from meters to millimeters real easily by using the SI prefixes. I know that in 1 millimeter, 1 mm, I have 10 to the -3 meters. But I'm going to need to cube that, so I'm going to put a cubed here. That cube's going to go inside to both units. But that'll let the meter cubes cancel and be left with millimeters cubed. So I'm now left with the appropriate unit. And so putting this in your calculator is going to be important. And you're going to need to know how to put cubed factors in your calculator. So come talk to me, or let me know if you have trouble with that. Please come see me in advance, before the quiz or exam, if you have trouble with that. When you put this in your calculator, you're going to have to cube the 3.281 and the 10 to the -3. So in your calculator, specifically, you're going to put 0.2587. Then you're going to divide by 3.281 cubed. Then you're going to divide by 10 to the -3 cubed. Doing that and getting an answer with 4 significant figures should give you 7.324 times 10 to the 6. So, take-home message from this slide, aside from me needing to double check my typing. If you need to do conversion factors that involve cubed, you can still use conversion factors that are published or known to you, like with the SI prefixes. You just need to make sure that you cube both sides of that conversion factor. One more to round out this chapter. Let's go ahead and do a sort of a math problem and a conversion problem and incorporate density, that topic that we talked about with regards to physical properties of a substance. Let's kind of wrap up all those concepts into this question. And they said, what is the mass in kilograms? In kilograms of 2 cubic inches of gold with a density of this? And I read this and I see, okay, I'm looking for mass. I'm looking for M. And I have something in 2 cubic inches. Ooh, cubic inches. That's going to be a volume, right? It's going to be a volume. And I gave you a density. So, it's looking, hopefully what things are clicking that, oh, I remember from the previous video, the density equation, density is equal to mass over volume. I have density and I have volume. I just need to solve for mass. And remembering your algebra rules, remembering you can cross multiply. You think about like density is over 1. If you cross multiply, you can rearrange this equation to solve for M. So density times volume is going to be equal to the mass. But before we start plugging things in, I need to make sure my units are going to cancel appropriately. My density is in grams per centimeter cubed, but my volume is in cubic inches. So I'm going to have to convert, for my units to cancel appropriately, because I've got centimeters cubed in my density denominator, I'm going to have to convert my inches cubed to centimeters cubed. That's not going to be a problem. We already talked about how to do cubes. We said that in 1 inch, there's 2.54 centimeters. And we need to cube that. So your inches units will cancel. So in your calculator, you don't need to cube the 2. It's already cubed. So it's 2 times 2.54. That you do need to cube. So you do need to cube the 2.54. And doing that, you should give you this answer. It comes out of your calculator. But remember, don't round it or do sig figs just yet, because we need to go ahead and use that, we need to go ahead and use that number to do our density equation with. So we have our density multiplied by our volume, so our density was given. We calculated our volume here. When you plug that in your calculator, centimeter units cancel, you get grams. What spits out of your calculator is 632.5, specifically grams. There's two things we need to do though. We need to realize that that needs to be in kilograms, and we need to make sure we have the proper number of significant figures. So let's think about significant, well, first let's go ahead and convert this into kilograms. So there's 10 to the 3 grams in 1 kilogram. So in kilograms, this would be 0.6325. That would be it in kilograms. But now let's think about sig figs. So we multiplied, so we care about total number of sig figs. My density, it's got 3. My volume, what does my volume have? Well, I calculated it up here, and my conversion factor has infinite sig figs. This just has 1 sig fig. 1 sig fig. So this number is only significant to 1 digit. So my final answer for this problem in kilograms should only have 1 sig fig. So the final answer for this problem is 0.6 kg. Okay. So I like this problem because you had to sort of know dimensional analysis, unit conversion, as well as rules for significant figures. So I would encourage you to try and work these problems again on your own. We're going to do other examples on the recitation worksheet and in-class examples. But that, my friends, is the end of Chapter 1.